let's take a look at a couple of examples of applications with radical expressions. The Pythagorean theorem states that if a right triangle has legs A and B with hypotenuse C, then a squared plus b squared equals c squared. The hypotenuse is the longest side on the triangle, and it's always opposite the right angle. That right angle being that perfect 90-degree angle. It's also important to state that even though the Pythagorean theorem was named after the Greek mathematician and philosopher Pythagoras, the theorem actually has shown in many places throughout ancient history. There's evidence that over 1,000 years before Pythagoras was born, this relationship with right triangles was known to the Babylonians. We call whole numbers that fit this pattern Pythagorean triples, and Pythagorean triples are found in lots of different places. India, Mesopotamia, China, many years before Pythagoras was born. This tablet is from Mesopotamia. It's called Plimpton 322. It's a Babylonian clay tablet. And deciphering these glyphs shows Pythagorean triples, 3 whole numbers that fit that equation, that make that equation true. There's a lot of fun research done on the Pythagorean theorem. With this relationship, we can find missing sides of a right triangle. And this can lead to some really rich questions in trigonometry and calculus, which is why we're talking about them here. So we want to use the Pythagorean theorem to find the unknown side of each right triangle. Let's take the one on the left. I have a leg with a measure of 3, a leg with measure of x, and the hypotenuse with measure of 6. So we want to make sure we put them in the right place. The only thing that we really have to focus on is 6 is C. A and B don't matter, because when we square and add them, it doesn't matter what order we put them in. So 3 squared plus x squared equals 6 squared, and we want to solve for x. 9 plus x squared equals 36. I'm going to move this up here in the middle, and then I can subtract 9 from both sides. 36 minus 9 will give me 27, and I can take a square root. Now here, I would normally put a plus minus, but measurements aren't negative, so we only have to worry about the positive x value, and 27 I know is 9 times 3, so x is 3 root 3 in solving that equation. Keep that answer in that simplified radical form, 3 root 3, don't worry about getting a decimal answer for it. Try the right one on your own, pause the video, and I'll have the answer for you. And did you get the square root of 31 for your answer? Good job. This idea of the Pythagorean theorem gives us the distance formula. We can draw a straight line between any 2 points, and we can find the distance using our understanding of right triangles. We have 2 points that we're looking at, x1, y1, x2, y2. We can create a third point, which gives us a triangle, x2, y1, by dropping a vertical line down and a horizontal line across, so we have a right triangle. Then our distance is the hypotenuse. One side is given by the difference in the y values, and the other side is given by the difference in the x values. So that when we use this Pythagorean formula, so here's Pythagorean theorem, we can plug in the differences in the y's and the differences in the x's, square them, and that should be our distance squared. Or, since we just want the distance, we take a square root. The absolute values disappear in the squares because 2 squared is 2, negative 2 squared is 2. We don't have to worry about the sign anymore when we square. And so that gives us our distance formula. Let's see how we would use this. We want to find the distance between negative 1, 2 and negative 3, 4. If I switch the points, it won't change the distance. The distance is always a positive number or 0. So distance equals, I'm going to put my x values in, negative 1 minus negative 3 squared. And then I'll put my y values in, plus 2 minus negative 4 squared. And then we clean it up. Negative 1 plus 3 squared, 2 plus 4 squared, negative 1 plus 3 would give me 2 squared. 2 plus 4 is 6 squared. So I have the square root of 4 plus 36, or the square root of 40. Simplify it. 40 is 4 times 10, so my distance would be 2 root 10 between those 2 points.